All right. Talk about supplementary, complementary, and vertical angles. And what you are going to have is a lot of writing to do. We're talking about 4 special kinds of angles today. So the first 2 are adjacent angles and vertical angles. You have to write some definitions. Yes, you are going to write them. I find that if you read them, then write them, and hear them, then that means you'll have 3 senses working. You'll have your eyes, that's your sense of sight. You'll be writing it, that's your sense of touch. And then I'm going to read them out loud, which is your sense of hearing. That's going to cover a lot of your brain. If only you could smell these definitions. Everyone sniffed really hard. Didn't work, darn. I was really hoping. I'm not going to ask you to come up here and taste these definitions. That's not going to be an effective tool. Don't lick your papers, everyone. Do not lick your papers. All right, so sense of sight, you're currently seeing them. Sense of touch, you are writing them. And let's also hear them at the same time. So, adjacent angles. 2 angles are adjacent angles when they share a common side and have the same vertex. Adjacent angles are kind of neighbors. They share a wall, right? They share a side. Those are the adjacent angles. So when you look at this picture, adjacent angles are the ones that are touching and are right next to each other. They share a vertex and they share a side. So number 1 and number 2 are adjacent. Notice how I can draw something connecting them. See how 1 and 2 are adjacent? They share this common side right here. 3 and 4 are adjacent, right? For that same reason, they share this common side. Somebody tell me another pair of adjacent angles. What would be another pair of adjacent angles? Angles that share a common side and are kind of neighbors. They're kind of hanging out next to each other. 2 and 3 are adjacent angles. They share this common side. Somebody else give me the last pair of adjacent angles. Yeah, 1 and 4 are also adjacent angles because they share this common side. Adjacent angles are the ones that are kind of right next to each other. Okay? Yeah. Great question. Let's read the next definition and find out why 2 and 4 are not adjacent. So, 2 angles are called vertical angles. Everybody say vertical angles. When they are opposite angles, so opposite, formed by the intersection of 2 lines. Vertical angles have the same measure. So, Ashley asked about 2 and 4. 2 and 4 are actually called vertical angles. Everybody, arms up like this. Now I want you to slide your arms so that your hands, your wrists are touching. 2 straight lines, right? What letter do your hands make?
V.
What letter do your hands make?
V.
V. These are vertical angles. Everybody, we're going to do this seal clap. Ready? Watch this. And now go like this. It's a sweet dance move, right? This is the vertical angles dance move, right? So the top and the bottom, ready? I'm going to smash these vertical angles. Smash. Vertical angles. Vertical angles. And what else are vertical angles? What else are vertical angles? Those 2. Those 2. These ones and those ones. These ones and those ones. That's the vertical angles dance. You guys know that? Sweet. As long as you're not doing like both, right? Because that's not vertical angles. Vertical angles are made when you have intersecting lines, and those are vertical angles, and those are vertical angles. The cool part about vertical angles is that they have what? Vertical angles have the same measure. That's going to be really, really helpful for us. What if angle 2 measures 73 degrees? What else will we know? That angle 4 measures 70 whatever degrees I said. 73 degrees. That means that angle 1 would be 107 degrees. We'll get to that in a second. Angle 1 would be 107 degrees, which means that angle 3 is, that's going to be really helpful for us. So they are opposite angles. They're the ones that are opposite of each other. They do not share a common side. So 1 and 3, if I trace them, there's angle 1. Does it share a common side with angle 3? There's angle 3. Do they share a common side? No. What do they share in common? What do they have in common? Starts with a V. They have a common vertex. Okay. All right, let's get to the next set. Complementary angles and supplementary angles. Yes, you have to write these definitions down. I want you to write them down. That's not a good idea. The vertical angles box is bigger.
was like, why is it so small? It's higher than
All right. Two angles are complementary angles when the sum of their measures is 90 degrees. The sum of their measures is 90 degrees. That is an equation. What is the equation?
Add two numbers together.
And set it equal to equals 90 degrees. Notice the sum of their measures equals 90 degrees. So that would be, if angle 1 and angle 2 are complementary angles, then you can say that angle 1 plus angle 2 is equal to what? 90 degrees. So that's because the wording literally says when the sum of their measures equals 90 degrees. So since angle 1 and angle 2 are complementary angles, you can add their measures up to equal 90 degrees. Just like that for supplementary, and you should be writing these definitions down. Two angles are supplementary when the sum of their measures is 180. That's an equation. You with me on that? The sum of their measures is 180. Which means if angle 3 and angle 4 are supplementary, what can you tell me? Angle 3 plus angle 4 is what? 180. Now, why? What did you see here? What is that? It's a straight line. So angle 3 and angle 4, if you can go like this and make a straight line, it's 180. Y equal to 90 here, what do you see? A right angle. Right angles are measured 90 degrees. Okay? And what about these? These aren't touching. But what can you tell me about these? If angle 1 and angle 2 equal 90, what can you tell me about these? 30 plus 60 equals 90. That's why these two are complementary. I think of it as this. Complementary corner. Everybody say complementary corner. Corner. Why do I think corner? Because a corner is a right angle, right? Except in my room where it's, 120 degrees. But that's a 90 degree angle, right? That corner and that corner. Supplementary, I think supplementary straight line. Everybody say supplementary straight line.
Supplementary straight.
And I know that a straight line has 180 degree measurement. So complementary corner, 90 degrees. Supplementary straight line, 180 degrees. That's how I memorize what those mean. And yes, unfortunately, you'll have to memorize those definitions. Because I'm going to tell you a problem like this. I'll say, angle 3 is supplementary to angle 4. If angle 4 measures 80 degrees, what's angle 3?
100.
It would be 100. And that's you'll have to know what the word supplementary means in order to solve that kind of problem. Okay? All right. Let's get to the other part. So you've got your definitions. Let's name this angle. What did we learn from our con lesson? How can we name this angle? First off, we have an angle symbol. Angle what? How would we name this? CAB. Is that right? Let's trace that. I heard CAB. So if I start at C, then go to A, then go to B, I have found out that this is unfortunately not CAB. Let's try again. This is angle what? CBA? Or angle ABC. What do you notice is in common between these two? B is the middle because B has a special name. B is called it starts with a V. It's called the vertex. Good. B is the vertex. So you can start on either of them, but B must be that center one. This angle could also be called angle B because there are no other angles that share that vertex. If there are other angles that share that vertex, you cannot call it angle B. Lastly, I want you to write a number in the angle. Let's call this 5. Is that the degree measurement of this angle?
No.
No, it's clearly not. 5 is not that. So you could also call this angle 5. There are 3 ways to name an angle. This is the best way, in my opinion. However, you might also see an angle named just by its vertex. You also might see an angle named by a number. That number is just telling you which angle it is. It's not telling you the degree measurement. So for today, though, we're going to use the 3-letter names. Here we go. Let's name a pair of adjacent angles. Now, of course, there are going to be lots of different adjacent angles in this picture, but I just want you to name a pair. I want you to tell your partner a pair of adjacent angles, and then I want your partner to come up with a different pair of adjacent angles. Ready, set, go. Use 3-letter names. So tell your partner a pair of adjacent angles, and then partner tell them a different pair of adjacent angles. All right, cool. Let's bring it back in. So this is the pair of adjacent angles that I made. Angle CFB. And then I made angle AFB. What do you notice in common between my adjacent angles? F is the vertex, and they both have B. They both have B. Because they have to share a common side. Which side do my two angles share in common? FB. They both share FB in common. So when your adjacent angles that you wrote down, there better be two letters that are exactly the same, and one of them needs to be your vertex. Could I have named this CFB and BFA?
No.
I absolutely could have. I could have. CFB is right here, and BFA. I'll show it in another way. Here's angle CFB, right here. And then here's angle BFA. Notice what they have in common? That's center side. Now, of course, you may have a different one than me, but that's okay. Ashley.
So for adjacent angles, they should be next to each other. They don't have to be the same degree.
They do not have to be the same degree. Adjacent angles. What does adjacent mean? Next to. It means next to.
So could you do DFE and AFB?
So Ashley asked, can I do DFE,
I mean D.
DFB? DFB and AFB. So DFB is this angle, right? And AFB is that one. Do they share a common vertex and a common side? They absolutely do. So are they adjacent? Yes, they are. All right, vertical angles. Tell your partner a pair of vertical angles. See if you agree on them.
Yeah, straight.
There are two sets because there's two lines that are crossing. And that was enough time. I chose these two. Anybody else choose those same two? Anybody choose the two that went left and right? Anybody choose BFD and AFE? Those are tougher, yeah. They're tougher to see because of that ray coming out the side. But what do they have in common? Just their vertex. They share no common sides, so they should have no common non-vertices, right? They should have just a common vertex. All right, complementary angles. There's only one pair of these. Tell your partner what they are, and then you're going to tell me. There's only one pair of these. There's only one pair of complementary angles, and they are what? Who's got this one? What are the pair of complementary angles? Lolly, give it to us. Angle DFC, that's this angle right here. All right, that's that one. And angle what? CFB. Oops, I wrote a D on accident. CFB. Why are those two the complementary angles, Lolly?
Because they like meet
And form, what do they form?
right.
A right angle. Those two add up to 90 degrees. How do I know they add up to 90 degrees? Because of the right angle. All right? Could I have written CFD? Yes. Could I have written BFC? Yes. All right. There are several pairs of supplementary angles. I want you and your partner to discuss 2 pairs and write one down. Go.
So 180.
Oh, I know.
There are several pairs that will work.
DFA.
Careful, DFA is a straight line. There needs to be two angles that add together to form that straight line.
You could do some examples from your adjacent.
There can be repeats. All right, here we go. Name a pair of supplementary angles. Who wants to share their pair of supplementary angles? Madison, what do you got? Careful, we said D. Oh, let me use a lighter color so we can see it. Let's use orange. You said DFA. Uh-oh, what is that? DFA is a straight line, which means that it cannot be supplementary to anything. DFA is a straight line. I cannot have it be a straight line. Want to give it another shot? Okay. Somebody else jump in here? Kobe?
No, I was thinking DFE
Okay. DFE.
and AFE.
And angle AFE. Notice when I connect them like that, what do they make? An angle AFE. You are absolutely right. That is a pair of supplementary angles. Because DFE and AFE, when they combine, they make that straight line, which is 180 degrees. What's another pair? Did anybody come up with another pair? Tori?
DCB and BF.
Wait, hold on. DCB? Is that what you said?
Oh, wait, no.
Yeah, we can't have DCB. That would be this angle here, which is not an angle in our particular picture. Aiden? Which one? AFB. AFB and CF what? CFD are unfortunately these two. Notice how these two, this angle and that angle, do not combine together to make a 180 degree angle. Let's stick with Aiden's first angle though. AFB and DFB. That's this angle here. Sure enough, that is a pair of supplementary angles, as long as they add up to form a straight line. Now the last part of our notes today is we need to classify each of these angles and then use the definition to help us solve them. So, the very first one, let's number it number 1. Number 1, what kind of angles are those? Everybody said together? Complementary. So write it down. Now how can we find the value of x here? What do we know from the instruction or from the definition? What do we know? So I'll stick with you.
It forms a right angle, so it's 9 degrees.
Good, so then these two should do what? They should add up to equal 90 degrees. How do I get x by itself? Subtract from 90. And I get that x equals what?
55.
Oh, 55, not 65. 55 degrees. All right, let's do number 2. What kind of angles are those? They are vertical angles. They do not share a common side or common, they do share a common vertex. Those are vertical. And we know from the definition, what does it say about those? Hey guys, we shouldn't be packing up. We still have 5 minutes. Still have 7 minutes. They have the same measure, which means that I can set these two equal to each other. So x equals 128. That one I didn't have to do any solving for, did I? That's kind of nice. And then the last one here, number 3. What are those? Supplementary. And what can you tell me about supplementary angles? Supplementary angles form a straight line, which means they do what?
Add up to 180
They add up to equal 180. So 117 plus x equals 180. And yes, I know that you can just subtract from 180. I get that. But these are nodes. So we should show the process of why are we subtracting 117? Because that's the inverse operation. And x then equals, what was it, Harzukman? 63 degrees. All right? Questions on those three? Coolio.